1, 2.
There we go. All right.
Yeah, it's going to be hot, especially if you're showing code. People more hot.
But it's just, I mean, that bit there is out of focus currently, and that's the native resolution.
Have you guys met Nicole?
Yes.
Okay, cool. By the way, congratulations.
Thank you.
Second place. That's good.
Very excited. I'm going to be getting talking and running away to go get on a bus and go up to the airport as soon as I'm done.
Yeah. Where are you heading?
Back to Boca.
Oh, back to Boca. Okay.
Yeah, I'm just here for today and
Right.
yesterday. I wasn't invited to the next couple.
Yeah, you should be all right. The storm's not going to be
I
bothering
think
anybody
it's
till
okay.
tomorrow.
Well, you guys will probably be fine. By Thursday,
Mhm.
it should be gone.
Yeah. We hope. Because I have to be back here in Alpharetta on Monday, so I wasn't planning on staying the weekend.
Probably wouldn't be ideal.
Yeah.
One, two, 1, 2.
Gordon and Bob together again.
Please rephrase.
Yes. Teaming up again. Yes. It's that DeHilster guy. All right. So I'm going to welcome everybody, and then I'll introduce you, and then you have 5 minutes or less, whatever you want.
We'll see. I was checking on you.
Yeah, hi.
We're all set. Everything's up and ready to go.
Yeah.
Good.
We were hoping to see if we could get the remote to present it.
You don't have a clicker up now?
Not a clicker for the iWatch. I can pick up that's okay. No, the projector there is slightly out of.
Oh, I see what you're saying.
Yeah.
All right, I'll be right back.
Thank you.
Hey, Thomas. This is Kendra. I'm in Rockland Community, and we need some additional tools for network.
So David, you're pretty tall. Maybe you could just reach up there. Turn the lens.
We've injured, so that's it. Have no cups tonight.
Then you'll try it.
Nice and blurry. Yeah. No. Right. It's just
You've been getting headaches.
ditto.
Well done, Gavin. I noticed
Well
you
done,
left
sir.
your own name off the incoming book.
Loved your presentation. Well done. It's just not focused. Projector's not focused. Yeah, see?
Well, just squint. Just squint. This is October 9th at 3:30. Butler Ballroom B, should be user interfaces visualizing the
Yes.
data.
But outside the door, it says something different.
Sorry about that. You can come into, he's here. Okay, good.
It was wrong. The sign was wrong.
Oh, is that what it was?
This is gonna be interesting or what?
Just have to get the slides. Everything's blurry on the projector. I think it's the projector. All right, it's 3:30, everyone. We're going to get started here very shortly. This is Gordon Smith's Visualizer Bundle presentation. So if you're here for machine learning, like, yep, you've come to the wrong place. All right, just a few technical difficulties. We're trying to get the slides in focus. How do they look now? Are you starting the live stream yet?
Yes, sir, it is streaming.
It is streaming right now?
I'm waiting to,
All right. All right, good afternoon, everyone. All right, everyone's still awake? Fantastic. All right, we're going to be starting with poster presentation. My name is Bob Foreman, and we are live streaming right now, so I want to welcome all of you out there who are live streaming the breakout session. So before we get started, we have a poster presentation, and we're very proud because she came in second place, you know, so that was a really great job. So, I want to introduce Nicole Navarro, and her poster presentation was Measuring the Geo-Social Distribution of Opioid Prescriptions. Nicole?
Thank you. For those of you guys who don't know me or I haven't met yet, my name's Nicole Navarro. I recently graduated with my master's degree from New College of Florida, and while I was doing that, I did an internship with LexisNexis, and during that time, we did a project working with patient data and prescription data to try and kind of find a new perspective on the opioid crisis. Typically, when people look at the opioid crisis, they look at individual prescribers, maybe they're overprescribing, what can we do about that? Or individual patients, maybe they're abusing the drugs. And instead, what we tried to do was look at how are patients connected to each other and how are they spread out geographically. And what I did as this part of this project was build dashboards that kind of looked into these issues and enabled the users to kind of investigate in these issues in whatever direction they chose. And so looking at these specific features, I was able to use the data science portal, which is able to create dashboards directly from data within HPCC. And kind of the best part about this is that we were able to create this iterative process between the data in HPCC and the dashboard so we could test out different things and say, what do we need from this data? What are we missing? What can we go back and add to it to help us create the best possible tool for the user? And so in the end, we were to be able to create these dashboards that really allowed the client that wanted them to investigate this and be able to find specific social groups that may all be receiving the same opioid prescriptions, and as well as certain communities that are receiving a lot of opioids for potential intervention or education programs. So that's about it. But thank you guys.
We have a little time for questions if anyone has any questions for Nicole. All right, no? All right, yes.
Yeah, we definitely did. We can't really show them on the dashboards because we had to anonymize the data, but we were definitely able to find these groups of people where typically most of the patients in the data, you'd have 2 or 3 people you knew with opioid prescriptions, but we were able to find these groups of 20 or more people that are all living close together in the same cities, all connected and all receiving the same exact opioids, which is very fishy, to say the least. So. Oh, and so another dashboard that we created was able to find specific communities that potentially had 40% or 50% of the patients in the data were all using opioids. And when we investigated it further, we found that these were specific Native American reservations, and looking into it even more, we could see that they were currently in legal battles with these opioid manufacturers over the fact that they were overprescribing in these communities. So, and we were able to see that just in our dashboards with no prior knowledge of it. Yes? It comes from a customer of LexisNexis. Yeah, it is. Yeah, not the region that's on the map, but we moved it around to anonymize it, yeah. I think they're still kind of trying to figure out who that really falls under. But.
All right, well, thank you again. And yes, absolutely. A lot of hard work. So, I have the pleasure and opportunity now to introduce to you a guy I've known for over 20 years. And when I first met him, I think he was working on on another product, the list box formatter and the data dictionary. But I've known Gordon to always be the guy to work on tools that make our development experience a lot better. So he's now moving on into some really cool visualization stuff, introducing that he's already introduced part of it in 6.0 and now into 7.0. So, without further ado, let me introduce to you, all the way from Cork, Ireland, Gordon Smith.
Thank you, Bob. Bob never remembers, but I always like to tell the story. Bob trained me in 1994, back in when he was a trainer with Clarion, and I was over in Florida on a junket, so it was a good time. Anyway, yeah. So what we're going to talk about today is the visualizer bundle. The goal of the visualizer bundle is to allow ECL developers to essentially inject visualization specifications directly into their ECL code. And it's aimed at ECL developers, so there's no JavaScript required, there's no HTML, no technology stack required for this stuff. It's about 2 years old now when we did the first release. And the way it works is it embeds a light web page into the work unit archive that is compiled, that comes out of ECLCC, which gets submitted to the platform. And you can, we'll have a closer look at this later, but you're able to embed any resources. It could be a WAV file, it could be an image. In this case, we're essentially just going to bundle in a very small, lightweight web page in with the archive. And then the way you look at these resources is from the work unit details page. There's a resources tab. There's one little trick in ECL Watch that if it spots an index.html, it'll go ahead and just load that up straight away so you don't have to manually select it. So, another year, another version. Gavin lied about 1.1. I decided to bump it to 2.0. It's not the only thing he lied about, but I won't. So, yeah, the main change is that we bumped the underlying visualizations to be in line with the latest version of the visualization framework, now under the moniker HPCC JS. Now, the only reason we have that new scope name is because we include some items which aren't visualizations. So we have a whole communications layer, which does nothing but talk to work units, get result sets back, talk to Roxy services, get result sets back, submit work units, and such like. And it's the same layer which sits underneath the VS Code extension. We have some replacements. We've deprecated the old grid. We've deprecated the hands-on grid, and they've both been replaced with the D grid. Don't worry about the terminology there, but it's essentially the same grid that you see within ECL Watch. So we've wrapped that up, and it's available now within the visualization framework. We've introduced some new visualizations. We have a radial bar in the 2D category. We have a new radar visualization in the multi-D category. We've got some new visualization categories. We've got a 2D linear. We already had a 2D category, but the 2D linear is when you've got linear values both on the x-axis and the y-axis. So your classic example would be a scatter plot. We've got a new category called relational, and these are the spider graphs. So, and we've called them a network visualization. We won't be really looking at any of those today, but they follow the same pattern. And then finally, we've got really a proof of concept called the Autodash, and that's using some of the design patterns stuff which Dan Camper hasn't written yet. Is he in the room? Anyway, so I nipped into the future, grabbed some of his code, and I brought it in here, so we're going to use that. A quick shout out to the Visualization Framework version 2, a shameless plug, and it's here to make sure my internet connection is working, which it is, good. Yeah, so this went 2.0 a couple of months ago, about 2 months ago. Since then, we've been scrambling to catch up on the documentation, but we have a bunch of docs there now, if people are interested, and I'll probably just do a shout out for the gallery view, which essentially tests our internet connection here. Get off your phones. Yeah, basically, it's pulling directly from GitHub a bunch of different samples that were written. We're up to 85 worked examples now, but you can delve into any of the various categories that we've going on here. But the key thing is, and I should probably, for each one of these worked examples, there's an interactive playground where you get a small snippet of JavaScript, you get the visualization, what you can see, and then you've got, it's published properties, which is a summary of the API. So here, for example, I might want to change the orientation horizontal to vertical, or I might want to change the whatever features. But this code section here is live, so you can go in and edit the data. So it's really a learning tool for the visualizations and how to play with them and learn how to use them. But because we're not dealing with JavaScript today, we're dealing with the ECL and how to do it. We're going to stick with our ECL hat on. Bundle installation, nobody else talked about this, but they're really simple to install. There's several different ways you can install them. All the landing pages will have the instructions, but the way I like to do them is just to install them directly from the Git URL. So this literally goes to GitHub, pulls down the source code, and then does the bundle install. Whenever you install this bundle for the first time, I recommend you run the self-test, and you do that by importing the visualizer and run visualizer.main. And what that will do is it will create a new work unit, submit it, then you open up the work unit in ECL Watch, and you go over to the Resources tab. And when you click on that, you'll know everything's working if you see something that looks vaguely like that. So these are the, sorry, it's very blurry. So the visualizations we're looking at here are the new D grid. We've got a bubble visualization, a pie, everybody knows, a summary widget. We've got two scatter plots. One is linear, one is ordinal. We've got the radial bar, column, a word cloud, needs more data to look better. We've got two multi-series line charts, one's a step chart, one's a regular line chart, radar chart, area chart. New, these are both in the linear category, the 2D linear. We've got the contour chart, a hex bin chart, a very small spider diagram, the relational network chart, and then some choroplets. So that's basically a summary of what's available within the visualizer bundle. Inside the visualizer bundle, each of the sets of visualizations are categorized into their own little namespaces. And we've grouped them together like this so that similar visualizations will take in certain data shapes. And they're really quite straightforward. For a two-dimensional visualization, like a pie chart, it's expecting a data set with two columns, a label, a string value, and a value, a numeric value. Then the 2D linear one, which I mentioned, is value, so that's your scatter plot. The multi-D ones, the multi-dimensional ones, which are your line charts, your multi-line charts, your multi-column charts, and such like, take again a label and then as many values as you would like to throw at it. The choroplets are, again, they follow the sort of label value pattern, except for it's a location ID, and it'll depend on what choroplet you've loaded up as to what that ID actually is. But the common example there would be the US states and GA for Georgia, FL for Florida. We've got the relational one, which I mentioned. It's slightly different. It expects two data sets, not one. But again, the data it's expecting it in is an ID, a unique identifier per node that you will see in the relational diagram, a label, which is the label you will see, and optionally an icon, which comes from the Font Awesome selection of icons. And then the second table expects a source ID. It's for the linking two nodes together, a source ID, a target ID, and optionally a label. So let's do a quick start. This is a hello world of a visualizer, of a visualized specification within ECL. So you import the visualizer bundle. You have a pre-canned data set. Most likely this will come from a grouped aggregate of some sort on your data. You output that data set to a named result set within the work unit, in this case. And then you call visualizer.2d.radial bar. You give it a unique identifier, my chart. And the reason we give them unique identifiers is later on when we want to string them together, when we want to have this interactive dashboard thing going on. The next two parameters dictate where the data is going to come from. So the data source, and we'll look at these parameters now in a moment. We're going to omit the data source, and when you do that, it means to pull the data from the current work unit. So it's going to go back to the work unit that this has been embedded into. And then the final one is the result name for this work unit. So it's chart data, so it has to match. Within the visualizer bundle, this is basically what the documentation or the comment section for each of the namespaces within the visualizer looks like. So for the 2D data, it's expecting 2 columns, the string and the label and the number of the value. So each one of those within the source file has a description of the data it's looking for. This is the common pattern for all the visualizations within the visualizer bundle. They all expect 6 parameters, of which the majority of them are optional. The first one is the unique identifier for the visualization, so my chart in this case. The next one is the data source. Where is the data coming from? It can either be a work unit identifier, a logical file, or an URL to a Roxy query. The second one is the second parameter. Oh yeah, on that parameter, as I mentioned, if you omit it, then it'll default to the current work unit. The second parameter is the result name from that data source. If the data source is a logical file, then you will omit this because there's no subfile within a single logical file. So you only have to specify the logical file. The next 3 parameters are inline key value data sets. And the mappings one is for mapping various fields out of a larger table. So maybe you've got a result set already in a logical file, which has got 28 columns. This lets you cherry pick 2 columns out of that for displaying in the visualization. The filtered by is the way we tie several visualizations together to create an interactive dashboard. And then finally, the properties are for setting visualization-specific properties, the dermatology layer, the look and feel, directly within the ECL. So if you want to change the palette color, or if you want to change from horizontal to vertical, and such like. So we just have a quick look at how the mappings go. So we say what the display label will be. So it's going to be subject taken, and that's going to pull it from the field ID subject. Same for exam year and year. So what we're doing is we're going to our nominated data set, we're plucking out the subject and the year columns, and we're mapping it into the visualization under the name subject taken and exam year. For the filtered by, this is how we tie together the various visualizations. So again, we do something very similar. This time we nominate the visualization that's going to filter this visualization. So in this example, my column chart is going to filter my current exam year based on the field ID year that's coming from the column chart. And similarly, from my pie chart, whatever the user clicks on that, it'll go off and it'll pull the subject field data, and it'll filter this content in this visualization based on that information. And that's how we tie it together. If this visualization happens to be a Roxy query, we don't do client-side filtering on the results. We send those data as inputs to the Roxy query, so it happens up on the server. Then finally, the dermatology or the visualization properties, these let you specify the various look and feel type properties of the visualization directly within your ECL. So that's when you're doing the final fit and finish. So it wouldn't be a demo without a demo. So with this new bundle, the version 2 bundle, there is a tutorial. And I've got about 7 steps in there. So what I'm really just going to do now is I'm just going to look at walk through that tutorial, those steps. There is a README file, so you can follow it online as well. But step 1 is to generate some data. So this is the data generation sample from the programmer's guide. Step 2 is a small Roxy query. So this is going to compile that down for Roxy, and you're going to publish it. So now we've got our data set up in the background. And so what we're doing, the gen data stuff generated these files here, these 13 odd files. And the file we're going to be primarily using for the tutorial is the people file. And it's similar to the one which Dan Camper had up on screen earlier. So basically, it's fictitious people at fictitious addresses with some inline data like the state and the gender, which is the 2 we'll be looking at. So our first visualization. What are we going to do? We're going to we import the visualizer bundle. This one looks a little bit funny because it's pulling from the same source folder as the visualizer one is. So it's actually going up a level and pulling in the bundle rather than pulling in the bundle that you installed. So don't worry about that. We're pulling in the data dictionary, which is just another ECL file here. It's where we've declared the record layout and the data set declaration. So DD is that. So data set person, we're in VS Code, so we can press F12, it'll bring me straight there. So that's just what's in the data dictionary. So we're doing a grouped aggregate row count here, single table line on the raw data. We output that grouped aggregate called gender. It's already in, it's only got 2 fields. It's got a label and a value. So it's ready, good to go. We don't have to do any mappings. We name it, and then we say we want to do a 2-dimensional visualization. What type? We want to do a bubble visualization. And I'm going to press F5, and that's going to launch it. It's completed already. Click on the Resources tab, and there we go. So what we have is we've got just over 500,000 people are male, and just under 500,000 people are female, and luckily we don't have that third option. So, rinse and repeat. They always say that you need to repeat things. So the second visualization, exactly the same thing. We're going to do another group aggregate based on row count. This time we're going to do it on the state, the 2-letter state, and we're going to visualize it in a choropleth, a US states one. So the ECL is pretty much identical. We'll press F5. Click on the resources. Bingo, there it is. Now, at this point in time, what we might want to do is we might want to come along and change its palette to be, I'm going to stick to the script, blues. So the key thing we need to keep a note here is it's palette ID and it's gone to blues. So I'll save that. And we have our nice shiny blue choropleth. When I come, so the next step in the tutorial is, okay, I like that blues, but I want to burn that into the ECL. So 3B, what we are now doing is we're passing in the optional last parameter. So we're inline data set of a key value def type record structure and palette ID blues. So if I run that, we have that burnt into the visualization. So coming back to the next step, step number 4. I didn't mention it, but there is a namespace category called any, and it takes any data shape, and the only thing that's really in it is the grid. So you can pretty much throw any data at a grid, it's going to render because it's the same grid that ECL Watch uses to display data anyway. In this case, we're using the third parameter, the mappings parameter, fourth parameter. And we're going to pull out 3 columns. We're going to pull out the person ID, first name and last name, and we're giving it a little bit more readable names for when we display it. So we get a grid that looks very like the result grid, just with the nominated data that we wanted. Okay, step 5 starts to get a little bit interesting. So what we've done is we've taken our gender visualization from step 2, and we've taken our choropleth from step 3B. We've put them together. We've taken our grid from step 4. But now what we're doing is we're going to pass in the filtered by data set. So what we're saying is we want to display the same grid, but this time we want to filter by the gender field from step 2 visualization. We want to filter by the state field from the step 03B visualization. So by adding that line, we get the interactive dashboard. So if I click on Texas, we'll see everyone in Texas. Click on males, we'll get the males in Texas and the females, and so on. Now, next, step 6. We've taken everything we had before, but we're now adding a Roxy service into the mix. And we nominate the URL to the Roxy service. We nominate the result name that comes out of the Roxy service, because it could be several results coming out. We are doing a mapping, because we're going to display this inside our multi-D lines. We want to pull out a single label, which is, in this case is going to be the account number. And we're going to pluck out two fields. We're going to pluck out the high credit and the balance fields, and we're going to display it in the line chart. Then finally, we're going to do our filter by from the grid, and we're going to pull out the person ID, and that's the field that will get submitted to the Roxy service. So now we'll give it a quick test. Click on males, Florida, and there, and bingo. So the last one is actually coming from a Roxy service, which is why it's nice and fast. So at this point, we actually have something that we kind of like, and we might want to show to our boss and get Lisa's approval, because we desperately need that approval. So we'll do a little bit of, just a little bit of formatting here, changing the layout. At this point, we might do some more dermatology changes. We save it, and then here we've got a link directly to that dashboard without all the ECL watch guff. So we can right-click that, just copy the link address, stick in an email to Lisa, and she can go play and berate. So finally, and this is really this is the proof of concept I mentioned, which is the auto dash. And whenever you see the word auto in an API, it's always a good thing. So how this works is you just give it one field, essentially, the logical file name. And it's going to do a bunch of trickery, some which Dan talked about, and some of the introspection stuff which Dan mentioned at the very end. So it's going to extract all the fields from that logical file. It's going to do the cardinality thing, which Dan's data patterns does. But the bit that Dan hasn't coded yet is it's going to also come back with the low cardinality fields and the record counts as well. So that's something which it will show up in the data patterns. And once it does, we will switch over to start using the data patterns. So if I run that on the people data set, this one actually takes a slightly longer to run because it's doing a bit of work for a change. So we'll refresh that. It's completed. Click on the resources, and this is what it'll throw back at you. And again, it's all tied up, and it's interactive, so we can look at the males inside Colorado. And these are middle initials here, of which there's 27 unique middle initials, the 27th letter being none, the blank. And you can literally throw any logical file that's out there, and it'll do its thing. So I've just thrown the other kind of main file from this sample data, which is the account stuff. And in this case, we get some more low cardinality ones, which make good candidates for filtering. So again, we could pick the account information. Now, Dan also alluded that he'll be doing, in his next phase of work, he's going to be doing sort of data recognition. So when we see a low cardinality field, which has got maybe 56 records in it, and they're all 2 characters, and every single one happens to match a US state, we're going to swap out the visualization there for a choropleth automatically. So how does it actually work? It's quite simple. The user imports the visualizer bundle. When ECTL-CC compiles the ECL, it spots that right beside the visualizer bundle there's a visualizer.manifest. The manifest contains the resource, the external resources information that need to be included in the archive. ECL-CC will then take those, convert them to base64, I think, inject them into the XML that gets submitted, and that's how it gets up to the server. And that wraps it up. Some useful links at the end. And any questions?
Ooh. All right. Any questions?
So if you visualize a grid, it will, normally ECL Watch will only show you the first 100 records, but if you visualize that person record set, is it pulling 500,000 rows in?
No, it's pulling 10,000 rows.
Okay.
But that magic 10,000 number is coming from one of those published properties that I showed on the right-hand side. So you can go in and you can lower that down or up it down or up it up. But
And you're still limited by a 10 meg work unit limit, or?
If your data source is a work unit, you are still limited. You won't have got your result set into the work unit in the first place if it's exceeded the 10 megabyte.
Okay.
So you're pulling from the logical file.
Oh, you are, okay.
If you specified the data source as a logical file, you're pulling from the logical file going through the new DA file serve, and you're passing the filter up to the ESP layer, so that's getting pushed closer to the data. I'm not pulling down the 10 million rows and then applying the filter. It's been done server side.
All right, anyone else? Yes, let me come back there.
Sorry, I don't want a Gavin question.
Is there a way to set up these graphing technique as a work unit that's deployed, and I can call it every time when I run an automation looking at the most recent data set? Like we have these load processes that run every day where we look at the last 7 days trend and then report it as part of the success email. I'm wondering if there is a work unit that I call which generates a visualization and then show me as a graph.
Well, you can nominate a different work unit that contains the data from within this work unit, which means you're going to be also generating a little bit of ECL with your mini dashboard in it to inject that work unit ID. Now, having said that, you can actually pass in, I have a debug mode where I can pass in a work unit ID on the address bar, which will redirect it to that. But it does a little bit more, it'll try and use local sources for the visualization stuff. It's my debug mode. So to do it out of the box today, you're going to generate, you'll declare your mini dashboard in ECL, but then you'll probably cut and paste that, and then you'll also generate that text with the changed work unit ID for the one that you want to pull the data from.
So there's not as such a web service that's available that will take a work unit, then template it, and then
There isn't, but you're talking about having a string of whatever your ECL is and doing a search, replace, and submit. You're getting close to all these visualizations here that we're doing purely in ECL. You're getting very close to, well, you know what? I'll just create a little HTML web page, which has got an entry box, which is the work unit ID. I'm going to paste into it, and I'll do up those visualizations. And first time around, it'll be a learning curve, but it's not a lot of code to get the same dashboards out, and you have far more control. So now you're looking at the visualization framework page and the communication layer there to do that. Pardon? Yep, it comes down to the URL. Basically, it's going through WSECL. Yeah, okay. Well, I mean, yeah, if you've gone to the bother of publishing a Roxy service that's going to give you the most recent results from the most recent work unit, then yeah, you design that dashboard pointing at a Roxy service, not at a work unit.
All right, anyone else? Any other questions? We are almost at 4:10, so we're going to take a 10-minute break. Those of you watching live, so you can take a break. We'll be back at 4:20 with our next breakout session, Arjuna, Chala. And how about a nice hand for Gordon? Thank you very much.
Thank you.
Well done, sir.
I didn't have to look at the blurry screen. I didn't have to look at the blurry screen.
No.
Oh, good.
Did you guys start with your own JavaScript, or did you start with something else like D3 or something?
All the visualizations we looked at today are using D3 under the So, oh yeah, it is.
They look familiar. We use some D3 for different things.
Yeah. And a lot of the visualizations are in the framework are kind of wrappers around existing ones.
Yeah, right.
But what the visualization framework is doing for you is that automatic property list and the serialization, deserialization. And the other stuff we do is, having designed the dashboard, we can pass it off to some of our internal tools like Hippie, which will also generate Roxy services.
It's pretty slick. Looks nice.
But this is really, it's for people to get their feet wet who don't have JavaScript chops. And I think the best value there is when you design, so you're doing address cleaning, and you can display a little dashboard that shows your
right.
results for your address thing. How
Super
many did I
quick,
pass? How
super
many
easy.
didn't? It's inline. You don't care about that final fit and finish. You just want to see, does my dashboard from today look like the one that was yesterday?
It's especially great for rapid prototyping to a business unit or something like that. It's super easy, super fast.
Yeah, so that's kind of the goal. And then if you want to get into productionalizing and front-ending it, then roll up your sleeves, get into the visualization framework, and there's a bunch of tutorials there, and it's one line. You point to the work unit, you attach to that work unit, and you ask for the results.
Hello.
Pretty much right shape. You do a little JavaScript map into the data structure. All the samples, you grab a sample visualization you like, put the job done.
It's pretty cool.
Cool.
Gordon, are you generating the top script directly in that, or are you using the DDL?
None of, in that, nothing, none of it.
You're not generating top script directly, or?
No. No, that one is the logic is in the mini web page I said I'm embedding.
Yeah.
Yeah, so the logic's just in that. So I've got some JavaScript which knows it's coming from the visualizer bundle. So it knows about the mappings, it knows about the filter by, because this kind of predates some of that stuff.
I know.
So it's not using any of the Marshall stuff or any of the pipeline.
Okay.
It's simpler, less moving parts.
I just wasn't sure if you were generating JavaScript or TypeScript or whatever to generate the web page, or if you had something similar to the DL that you were generating on the ECL set. I finally figured out how this app told me where I'm going.
You might be able to talk.
Okay, let's get started. Thank you everyone in this room, and thank you everyone in the live audience. We'll get started with the last breakout in this track. This is going to have two pieces as usual. First, the poster, it will be 5 minutes, and then we will have the presentation. That will be the rest of the time. So for the poster presentation, we have Matt Butler, who joined us as an intern a few months ago, and did an excellent poster in a couple aspects of autonomous vehicles. This is telemetry and some of the risk prediction, but also some tweak around cybersecurity of connected vehicles as well. So without more preamble, Matt, the 5 minutes are yours.
Thank you. Good evening, everyone. Again, my name is Matt Butler. My full name is Everett Matthew Upchurch Butler, so you can pick any two, and I'll know who you're talking to. I'm a senior at Kennesaw State University, information technology major with a concentration in information security and assurance. Like Flavio mentioned, I previously worked with the LexisNexis team in HPCC Systems in a software development capacity where I actually developed a standard math library for the ECL language. So my poster is about autonomous vehicles, specifically the future of automotive telemetry. And anytime I present this, I like to begin with the definition, and that is of telemetry. Telemetry simply means the process of recording and transmitting data. So I wanted to look at that and how it applies to autonomous vehicles. So I apologize, it's a little difficult to read on the slide here, but if you want to get closer after the presentation, feel free. The way I've divided this poster, the top section has a little bit of background information. Here's going to be a few examples of some conclusions I drew using HPCC, and then there's a little bit of information I'll get to regarding cybersecurity. So background information. Why does this matter? Why are we talking about autonomous vehicles? Well, for a couple reasons. One, experts are predicting that by 2030, just 12 years from now, 77% of all vehicles will be either level 3 or level 4 according to the SAE's guideline. What that basically means is the SAE, the Society of Automotive Engineers, which is the entity that the U.S. Department of Transportation relies on, has defined 5 levels of autonomous vehicles based on capabilities. Right now, most vehicles being created are about level 2, the modern Teslas, so that simply means that people think we're a lot further than where we are right now. But this is a technology that's going to be rapidly implemented in the very near future. Beyond just that, the insurance industry, the automotive insurance industry, is predicted to lose about $165 billion by 2050, which is over 80% of their total financial assets. So this is going to have huge impacts both in our society, in our behavior, and also financially on the economy. So that's why I feel like this was a relevant subject to actually discuss. So continuing on, a little bit of background information. This project focuses on risk analysis regarding autonomous vehicles using the big data platform from HPCC Systems. There was a simulated data set that took place in Cologne, Germany, that was actually created by the government of Germany, which included 700,000 individual data points related to vehicles. These data points included vehicle ID, X position, Y position, vehicle speed, and also timestamp in 1 second increments. So with those 5 pieces of information, I wanted to see what kind of meaningful conclusions could I draw by just querying that data and doing some really deep analytics on that. So in this first section here, this is just an example of one of the ECL codes that I actually wrote to query the data and return some information. I believe that this specific example actually returns the number of instances that a vehicle was going over the speed limit. A specific vehicle was going over the speed limit during a specific time period. So that's definitely something that an insurance company will want to know about. Moving on to the second example in the middle, that is an instantaneous traffic density map. What that means is, at any 1 second, where are all of the vehicles? Where are all of the cars that have this ability to track and log this information? Why would an insurance company want to know that? Well, for example, this is actually a map of Cologne, Germany, and also a XY position scatter plot of all the vehicles' XY coordinates at 1 second time increments. It's actually a direct overlay on the map. So if you're driving and you spend 90% of your time in the center of downtown where there's more traffic, there's more likely to have an accident, you're at a higher risk, you're going to have a higher insurance premium than you would if you spend the majority of your time on the outskirts of town. And I thought that was a really interesting point because the insurance company could definitely use something like that to determine your insurance rates and your premiums. There's also a route calculation. As an autonomous vehicle driver, you'll have an option of not only where you want to go, but how you get there. Maybe you choose a route that's a little bit safer because the infrastructure got developed first, vehicle to infrastructure communications are there, vehicle to vehicle communications are there. It's a safer route, but it takes you a little bit longer than the faster route, which might be a little bit more unsafe. Depending on what you choose, whether you choose the safer route that gets you there a little slower or the faster route that gets you there, but it's a little bit less safe, that is going to be able to actually look at and determine to see what your insurance rates would be. And that's another conclusion I was able to kind of draw and use the mapping with ECL. And the last part, like I mentioned, I am a IT student and my concentration is information security. So I thought it would be interesting to not only look at the risk associated with autonomous vehicles in terms of physical risks like car accidents, things like that, but also a risk that's difficult to measure, a risk that's difficult to quantify and put a number to. And that is the risk associated with having these technologies that are so interconnected. These vehicles are going to need to have software updates, they're going to need to have patches, they're going to need to be connected to the internet. So I thought it would be interesting to actually look at how these vehicles will be protected from a cybersecurity standpoint. So I thought it would be kind of cool to actually build a portable hacking, ethical hacking kit. So this is actually a Raspberry Pi 3 that I've installed with Kali Linux on here. And with something like this, I could have it in my car, maybe a backpack, a glove compartment, and I could be pretty much anywhere. I can attach a Wi-Fi extender, have additional range. I could be well away from your home, hack into your network, maybe find the hash key for your Tesla, unlock it. Maybe I turn your alarm off at 2 in the morning. Maybe you cut me off on the interstate, so I catch you at the exit and I turn off your brakes. Now, I wouldn't do that with my ethical guidelines, but someone else could. So I thought that would be a really interesting thing to think about. How do you measure the chances? How do you measure the risk that there's somebody like me? I think I'm pretty innocuous, I'll say. I think I'm a pretty safe-looking person. But how do you measure the chances that there's going to be someone near you that you have no idea about that has something like this? But that wasn't enough for me. So I also wanted to take a step further. I wanted to be able to control it from my phone. So I actually, if I can show you here, was able to control this device from my cell phone. So right now I'm running Wireshark, which is a packet sniffer. So if anyone is connected to the network that I have set up, which kind of looks like the Marriott network, which I don't believe anybody is, I would be able to actually see any information you're transferring from there. And I could have this again in a backpack, be behind you in a grocery store, be behind you at a red light or something else. How do you measure the chances that something bad is going to happen? You have no idea. And I think that's an important thing to consider in terms of risk as we move forward with this. So in conclusion, again, if you guys want a little bit more information, feel free to come up to me, ask questions. Again, I apologize that it's a little blurry to see up there, but yeah, that's it. So I appreciate your time. Thank you.
Great. Thank you very much, Matt. This was very good. And if you end up connecting to that device, you probably need to wipe your phone after that. Anyway, let's get started with the next presentation. This is going to be Arjuna, who will introduce us to VS Code and how VS Code is now very well supported in our environment. No more paying through installing Eclipse and running sometimes a little bit slow because it's kind of bloated. VS Code tends to be quite smooth running, and it should meet all of the features that you typically use in ECLID, barring maybe some of the classical features like the standard old repository. So without more preamble, help me welcome Arjuna to this presentation. Thank you.
Thank you, thank you. So how many of your Mac users would have loved to program ECL if you had a really good IDE like IntelliJ? So you don't program in ECL just because of that? So now I think no more excuses. I think with VS Code, I think you have a great IDE. Really, the capabilities of JetBrains IDEs like IntelliJ and the other IDEs from JetBrains built into VS Code. One of the things is obviously VS Code has been developed by Microsoft, so it's not like they started from scratch developing the IDE. It has several years of experience into IDE building. that's gone into VS Code. So the other aspect that is important is nowadays ECL programmers are not just ECL programmers, right? For example, in your case, you'd be doing ECL programming for an hour and then doing some DevOps tasks with PySpark or Py or Python or some other things and bring it all together. Instead of jumping from one IDE to the other IDE, you can do all that within the same IDE because VS Code has a very rich interface. It supports several different languages for you to be able to program in. Right. The other aspect is if you're doing any server-side programming, like you're using Java for Tomcat or any other technologies for that matter, PHP, etc. Now, there's a technology called Node.js. Have you heard of it? So Node.js is a very specialized non-blocking architecture. We'll go into a little more details about that. But it was really made famous by Uber. When Uber introduced their application, they needed the speed of interacting with a backend system that is non-blocking. And that's why you see the visual interface refresh so quickly because of this architecture. And Node.js is nothing but an application server of some sorts where you can deploy web services or you can serve up client-side code like JavaScript code very easily, very quickly. So now if you bring all this together, you bring ECL programming where you do your backend programming and shaping your data. ECL is fantastic at that, right? But now you want to show that quickly in a visual interface of some sort. You can do that using JavaScript or using Node.js as an application server very quickly and bring it all together in the same IDE. So that is the idea. So let's go through some of the different parts of the IDE itself. So primarily, you have the code editor. So obviously, this code editor would not be very useful for ECL if Gordon Smith had not put in the work and effort to bring the richness of ECL into the VS Code environment by creating a plugin. So one of the beauties of doing it this way is Gordon just has to write what is really necessary for ECL. But in addition to that, extension developers can go in and develop other plugins to annotate that ECL. For example, let us say there's a record definition that you want to import. That's hypothetical in the sense that plugin does not exist. I'm saying in the future, let us say somebody wants to import a record definition by pointing to a HPCC file remotely. Somebody can write a plugin, okay, in a few days. They can go and introspect what is there on the server side on the HPCC platform, look at the record structure, and then here in the code, we can have a cursor, and you can simply say with a few keys, import this record structure into my code base. So you can have also indenting built into ECL. How many of you miss indenting and formatting your code in ECL, right? Some of the basic things that you're used to while programming in other languages is kind of missing in your ECL IDE currently. But those things are what is coming in the pipeline to make it a much more richer interface, much more IntelliJ-like interface, where all these features like formatting, code formatting, linting, refactoring is all built into your ECL experience, right? So that's your code editor. Then obviously, you have the very rich file explorer. One of the things about VS Code is that the file explorer and the entire IDE can be themed like how you want it. Let's say you don't like this dark interface. I want a light interface. You can do it. There's hundreds or if not thousands of themes available for you to theme it like the way you want it. Okay? Then, in addition to that, let's say you don't like these default icons. I want something that's more descriptive of an ECL file, something that is more descriptive of a JavaScript file or a JSON file. You can have an icon theme installed on it. And the best part is, unlike Eclipse, you keep adding plugins and suddenly you see your IDE slow down, slow down, slow down. You will not see the slowdown here just because of the key architecture of non-blocking architecture, right? It's built on that Node.js non-blocking architecture, so you get ultimate performance on the IDE itself. So you have your search and replace, common things, and one of the most important aspect for an ECL developer, yes, for us, Java developers, JavaScript developers who are used to other IDEs, very common, right? There's a JIT integration into all these IDEs. But for ECL developers, in the ECL IDE, there's no Git integration, right? In fact, Microsoft also recently purchased GitHub. So what they're trying to do is make that experience with GitHub and VS Code integrated much richer than what it is right now. So it's going to be much more seamless. But even with this integration that exists with Git, it's an awesome experience to be programming in ECL and checking in, checking out code, etc. It provides the complete lifecycle around Git integration. And then run and debugging your code. Obviously, there's some limitations to debugging ECL code. We all know that. But very quickly, you can run, execute the code, and debug it like how you would do in any other IDE. Manage extension. If you want to install, uninstall extension, you can do that. And finally, if you have the ECL plugin installed, then you will see this additional tab for your ECL watch, which shows you all the executed work units, just like what ECL IDE does. So you can click on it, and it'll open it in the browser. Finally, the code outline, which shows you the different, if you have an ECL code file open, it'll show you the different functions in that file, all the variables, etc., like how we would do it in any other language. So I don't have to mention this. It works on Windows, right? So if you're a Windows developer, don't stay on ECL IDE. Try this. You might like it, especially with what Gavin was talking about this morning with regard to the enhancements in ECL Watch that is coming down in the 7.0 pipeline. You want to leverage that richness of ECL Watch and the graph enhancements and all this within the browser facility. So if you want to do that, you probably want to try to take a look at VS Code. Let's see. So you name it. Think of any plugin that you want that will make you a better programmer. VS Code has it. Spell check. Let's say you want to develop markup documentation, create your wiki. All are present as plugins within VS Code. So when you're creating a project, your project has many parts to it. It can have JavaScript, it can have markup, it can have ECL, it can have server-side code in the same project, same ecosystem, same repository on GitHub, but you can all manage that in a single place in the IDE. Very neat. So non-blocking architecture. Let's take a look what I mean by that, right? In typical use, you see a file read, and then in this particular use case, you see a blocking example where a file read happens, and then if you have a statement called more work at the end of it, it'll get executed only after it finishes reading the read file sync, right? Only after it completes that, it will get executed. But in the non-blocking world, it is a little different. This is critical for understanding why VS Code is so good. Here, in this case, you have a callback method saying that, okay, read the file, and then invoke the callback method if the file is completely read. In the meantime, just go to the next step. So it will not wait for the read file to complete. It will execute the more work immediately. As soon as it hits that file, and after the read file, it'll execute more work, even if the file is not read. Okay? So why is this critical? Because when you look at, go back to the different parts of the IDE, if you look at what is happening in the Explorer, what is happening in the outline, what is happening within the tree view, what is happening in the different tabs on the left side, what is happening in the code editor, all these work in a very asynchronous manner. Okay? One cannot step on each other, which is really critical. So that's why you will hardly see VS Code actually hang on you. Okay? If it does hang, that means you must be using a really bad extension that is built by somebody, right? And it's really fast, so that's critical. Brilliant for UI rendering, that's it. Okay, now let's look at a real use case, and a real use case that we have been very interested in on the open source side. And through several of these talks in the morning, you saw cancer research mentioned at least 2 times. I heard it 2 times. You must have heard it more than 2 times. It shows the importance of this particular subject. So we got involved in this area also because there is an interest from Cleveland Clinic, where one of my close relatives works there, but the interest was around, okay, you know what, you have these cancer-related data sets which show the historic trends of what is happening for different areas, different geographies. Now, can you connect that to, let's say, water sources in counties and see if there's a correlation, right? So specifically, you wanted to see what are the lead levels in the different water sources in every county and see if we can correlate it to the trends in cancer, increase in cancer or decrease in cancer. So how many of you think cancer rates in the US is currently increasing? Increasing. So everybody else thinks it's decreasing, right? Okay. We'll see the results at the end. Anyway, for this particular exercise, I really took a very small file from, you can go and download it from CDC. Anybody can go and download it from CDC. I was only concerned about a few attributes in this file. Okay, the age, obviously the count of incidents, the event type, right? And site is really what is the type of cancer, and the gender and year. So that was the interesting pattern. And what we wanted to do was, go to the CDC side, you'll see these charts, which shows you the trend year over year. You can drill down on a county, or not county, state, city, and also in general, very bland charts. But we wanted to go a little deeper than that. So to accomplish this, first, obviously, we want to set up VS Code, right? To set up VS Code, you have to do a few things. One, if you are completely starting from scratch, you need to set up the client tools for Mac, assuming that you're doing it on Mac, and then download VS Code, and then install the great plugin from Gordon called ECL Language. You can easily search that for the extensions plugin from the extensions tab and install it. By the way, I was in a training yesterday afternoon with some of the folks in the other room, and their ECL IDE crashed. Okay, fantastic, good opportunity for me, right? So go in there, try VS Code, right? Let's install VS Code. 5 minutes later, they had VS Code running everything working. They were executing their program very quickly, including installing all this. So it'll just take you literally 5 minutes to get it going. Okay, so for our project, we will create really folder structure like this. I just came up with the name DAS for this, but we'll talk about a little later what that really means. A client structure to store my JavaScript code, and an ECL folder to store the ECL code, and a server folder to store my Node.js code to serve up the client software, right? Now, this is a video that has to automatically play. So that's really the structure that we set up. Blank slate. So we add a folder to the workspace, in this case, the ECL folder. Just give it a name and save the workspace. Now you have to create a run profile for ECL. This is where you configure which server or which cluster that you want to connect to and execute. You can have n number of profiles, one for Thor, one for Roxy, one for this cluster, that cluster. You can have as many profiles as you want, and you can switch between them when you run it. Server address. Yeah, that's by default. It defaults to HStar. You don't want to use HStar. You want to use star, right? And just give it a, in this, by the way, I'm using the play.hpcsystems.com. It really does not need a username and password. I put a username there so that you can track what are the work units you execute. So it's set up. Now it's time to create a simple hello.ecl. Debug completed, fantastic. Let's go look at what the output is. Similar interface, opens it in the browser. Easy enough, is it not? What's that? Now, this is going to really enhance the experience, right? The experience around HPCC, ECL. People will start using HPCC more robustly because you find that there are certain advantages to using HPCC to shape your data, and we really want to enable them. What it's probably not good at is, how do we now create a dashboard out of that? Maybe you want to push it to something else, right? So that is where you create your dashboard or UI using JavaScript, and you can make all this work very quickly through the same interface, very quickly, very agile manner. So I'm not going to go through building this ECL application. What I'm going to show you is some critical steps, right? First of all, to complete this application, I needed the data set. That is what the CDC data set was all about. I needed to build some ECL queries. And then one of the critical things as part of this project was to create more of a server-side interface for dashboarding, where instead of enabling the dashboarding from the client side, we wanted to enable the dashboarding from the server side. In the sense, I should be able to register the the dashboard components from Thor or Roxy, and then it should show up in the UI. That was kind of thing. Because as soon as I started working with the data, there was like 100 different charts that I had to create. No, I'm not going to go and create this manually. I needed some framework to automate all this because all of them kind of follow the same pattern. How do I do this in a very automated manner, right? That was the key. And I wanted to do this through ECL because ECL enables me to shape the data very nicely. The power is there. Then I just wanted a small step where I can now register my dashboards within a super file of some sort, and then my UI would read that and render it as I want to, right? Eventually, create a UI like this. Simple, very simple UI, right? And, so then, after coding for not many days, 10 days, bringing it all together, seriously, I'm not making this up, 10 days of coding. Created a bunch of code, obviously, on the JavaScript side for querying this data, shaping this data, etc. And then also created the ECL queries. I used a framework called Google Polymer. I'm not sure anybody has heard or played around with it, but it's a fantastic tool set for developing user interfaces, obviously developed by Google, and it's based on material design semantics. Okay. And then the output of this was, I think this is an embedded video. Yes. So remember the question I asked? It's kind of plateaued currently. The cancers that are occurring on a yearly basis is kind of plateaued, but, and this is a drill down on the main chart to show it, a drill down of the age. So if you look at certain cancers, like colon and rectum cancer, it's actually decreasing. Fantastic news. So we're doing something right there. Whereas other cancers, it's actually increasing. Probably people consuming more alcohol is adding to this. Could be, right? So the next step is that. Next step is to bring this data together with other correlated factors and see how all this comes together. So this, in essence, was the framework and output created using VS Code. And we could do this rapidly only because the IDE provides you the capability to do all the pieces, JavaScript, JSON, ECL, everything in the same IDE. Otherwise, if I had to switch from one to the other and figure out how each one of them works, it would have probably taken me 30 days. It's not impossible, but it would take me a lot longer, okay? Some code samples, obviously, of queries that were developed. Client-side code. Server-side code for running the server. And this is what I talked about on this. So once the UI framework is created, you really want to create and add more dashboard, this is how you do it, and you would use ECL to do it. You register your dashboard, you register your charts on the dashboard, and that is it. And it'll automatically show up a new tab as an application. You click on the application, and you see your dashboards, and off you go, right? That is all I had. Okay, I think we're close to the time. We have more time. Perfect. Yep. Go ahead.
Yeah, a couple of questions. First, does the plugin support any kind of autocomplete, like type self?
Yeah, it does. It does.
Okay.
And it's Gordon is constantly enhancing that. I mean, literally every week you'll see an update to the plugin plus CC. So that's constantly being enhanced and made better. Yeah.
Follow-up question are there any plans to have the work units show up in the plugin itself in the IDE?
It is. There is an option to show that up. I prefer it to be external to it, but the way it does it is the same way it does it in Eclipse, right? Where it brings the web component. It embeds that within VS Code. I particularly do not like it that way. I would rather go look at it in the whole window. Yeah.
Questions? Today you used to going into the server side. Is the idea to use the service and then render everything on the VS Code itself in terms of the results and everything you could be running, even if you put it locally or from the server side?
You can. You can actually, if you really want to play around with this a little bit. Let's see. If you go to this GitHub site, this whole project, you should be able to check out, from GitHub, and a few commands to get the related libraries because it's based on Node.js. So you update, perform a few updates of the packages. It'll bring it down to your machine, and then you should be able to start your local server and see how it all works on your local box. And then you can go to the JavaScript files and start playing around with it. If you want to change some things, make updates, or add things, you can start playing around with it.
Is the code heat stuff working as expected when you have your JSON structures or the metadata? You're typing on other ECL codes, is already bringing into the scope or the project scope, all those variables?
Sorry, say that again.
The key thing is when you're talking about data fields and attributes, right? You start an ECL work and you have more than some file or there is some quick way to scan all those variables and have them listed there so when you type, you get the type of head assistance.
Right, so that is part of what the plugin is evolving into. First of all, there's a few things that is going on. One is the plugin itself is evolving into providing the more richer code completion facilities, like what you described. In addition to that, external to the plugin, we are building additional extensions which provide you a visual interface to connect to HPCC system, select a few files, say import, and it'll bring in the whole definitions for you automatically into the IDE, and you can program. Actually, if you're really interested, it is kind of bleeding edge. It's called HDPK, as in HPCC data package, on the same HPCC Systems GitHub site, and you can install that extension. It does that.
With the Arjuna developed a solution just to manipulate and visualize the HPCC data from the baseline and also from the input. So maybe something to look at there is the whole integration of all these data fields names.
Absolutely.
So you can do some quick and dirty fixes that you don't foresee it easily.
You love the HDPK plugin. That's exactly what it does too. So you can have, so what it does basically is once you import your HPCC definitions, it'll bring it as JSON first. So in the JSON, you can then add enhancements to it. Like for example, okay, I want to represent this field with this cleaning technique. I want it to be full name. I want it to be uppercase. It'll then, when it actually creates the ECL part of it, code definitions, it'll automatically translate that rules to that.
Probably if you'd like to bring the data dictionary parts, you can do that.
That's another project we are working on. Yeah. We are doing what you want. Yeah. The data dictionary is also very important for us, and we are doing that too.
And the profiling stuff they just presented there is something that is very key to be here, right?
Absolutely. We're bringing all this together. You'll see that coming together in the January timeframe. You'll see all this coming together nicely.
10 days, now you give me January.
Data dictionary is a different ball game altogether.
So, like, I want the
No, that is, for us to build an extension for profiling and putting it here is trivial. We can do that. That's a good idea, actually. I had not thought of it as a separate plugin. Okay.
It seems that it would be a good strategy to use the profiling to do the input and output assertions.
Yes,
That would be a very powerful.
absolutely. Yeah.
Very good. That's it. We don't have more time. We are
Thank
right
you,
on
guys.
the
Thank
edge.
you.
Thank you very much, Arjuna. And thank you very much to everyone in this room and also everyone in the live audience for the live stream. Now we need to conclude the day. Unfortunately, there is always an end to good things. So we'll conclude here. For those in the room, there will be refreshments right outside here. For those in the live stream audience, there are no refreshments for you, unfortunately, but there are more recordings. Go and listen to all of the other breakout sessions, which have been also great. Thank you very much. Thank you, folks. Have a great day.